So what we have so far is a way of duplicating a melon Kiley graph. But as Damien pointed out, we still can't duplicate the melon, or indeed even the surface of the melon, because not every point on the surface of the melon is on our graph. So here is how we're going to get around that. So forget about the points we've drawn on the melon for now, and just consider the set of all admissible rotations. So that's the set that you get after all possible paths of theta rotations about the z-axis and the x-axis. And say that points on the surface of the melon are in the same orbit. They're friends, as it were, if you can get from one to the other after a finite number of rotations of that kind. So all the points that we draw here are going to be friends of each other, because as we saw, you can get from one to the other by using rotations. And now we can address Damien's point, because now we do get the following observation. Every point on the melon is a member of some orbit. And every orbit is going to be, in effect, a Kiley graph. So here's what we've done. We've covered the entire surface of the melon into Kiley graphs. And it's a partition. So there is no point that's a member of two Kiley graphs. Every point of the melon is a member of exactly one Kiley graph. Now, there's something that this procedure doesn't determine. It doesn't tell us what the center of the various Kiley graphs are. In this case, you can tell what the center is just by looking. But that depends on the fact that our steps got smaller and smaller. Because steps don't get smaller and smaller here. It's not obvious just by looking what the centers are. So what we need to do is pick centers. And to show that it makes sense to pick centers, we need the axiom of choice. So we use the axiom of choice to say, select a center for each of the infinitely many Kiley graphs that cover the surface of the melon. And now we're almost done. Because what you can do is you can carry out the same duplication process for all of the Kiley graphs at the same time. So what you do is you say, OK, everyone check what quadrant you're in with respect to your own Kiley graph. So what everybody does is they figure out who the center of their Kiley graph is, and they check and see whether they're to the right of the center, to the left of the center, up of the center, down from the center. And everyone knows the answer to that question. And you say, OK, so everyone who's in the left quadrant of their graph perform a certain rotation. Everyone that's in the top quadrant performs a certain rotation. And when we all do it at the same time, what you get is you duplicate the surface of the sphere. So what we've done so far is duplicate the surface of the melon. Can anyone think about how to extend that to duplicate the melon? And a hint is that that is easy. That is very easy. Yes?
Just replace every instance of point in the proof there with a line to the center?
Exactly. Yes. That's right. So we know how to deal with the surface. But the melon, of course, is made up from lines that go from the center of the melon up to the surface. So when you perform the movements, just move the entire line. And that is the proof, or at least a sketch of the proof, that you can duplicate the melon.